Hello and welcome everyone to the second part of trigonometry. This is the part where we actually start introducing some of the new things, trigonometry. What we're going to cover in this lesson is labeling all three sides. So I mentioned in the first part, we have the hypotenuse, yes, and we've got the two shorter sides. Well, they actually have names. This lesson we will learn what those names are. It'll be super easy and pretty fun. And then the second part of this lesson will be introducing the actual trigonometric ratios, the things that we call sine, cos, and tan. And yes, I know on your calculator, it's just sin, implying it's sin, but there's like an E there, but it's not written. The button's a little on the calculator, right? It's sine, cos, and tan. All right, let's get into it. All right, so first part is labeling the sides. Here we can see, if we look at this first triangle right here, it has three sides. It's a right-angled triangle. So this fits right into our work on Pythagoras that we covered last lesson. So we know from last lesson that one of these sides is called the hypotenuse, which of course will be this one right here, the longest of the three. So this is our hypotenuse. I'm just going to put H there, right, for hypotenuse, just as an abbreviation. All right, now what about these two shorter sides? Well, if you look at the included angle, the 35 degrees, one of these two shorter sides is opposite it. It's on the opposite side. So if you take the included angle, go over to the opposite side, well, guess what? We call that the opposite side. I'm just going to, again, put O as an abbreviation, but that actually stands for the opposite side. And then the final side, what do we call it? Well, this final shorter side is next to the included angle. So the way we name the two shorter sides is based off where the included angle is. And by included, I don't mean the right angle. Every single one of the triangles will have a right angle. I mean the other angle. And the one that in this case is 35 degrees. So for the shorter side that is next to the included angle, because it's right next to it, we say it is adjacent. Adjacent is just a fancy word that means next to. Right, so if you've got someone who's sitting right next to you at the moment, you could say, hey, that person is adjacent to you. So they're the three names that we give to the three sides of a right-angled triangle. The hypotenuse is just the same from Pythag, you learnt that last year. The two new ones is the opposite and the adjacent. Typically, I label the opposite first because for some reason, my head always just finds the opposite a bit easier to do because it's on the opposite side. The adjacent will be the shorter side right next to it. You might say, hey, if you look at this included angle, there's actually two sides that are adjacent to it, right? There is the one that we called the adjacent, this one right here. And there's also this one. There's actually two sides that are adjacent to that angle, but of course, one of them was the hypotenuse, right? It already has a name. So it's the other side that's adjacent that gets called adjacent. If we look over at this second triangle that's been put here we can see the included angle has been put in a different spot. We actually don't know the size of this included angle. It's just been, let's just use the symbol theta. How do we label the three sides? Well, again, I would always start with the hypotenuse, the longest side, the one that is opposite the right angle. That's our hypotenuse there. I'm going to put a H there. For our two shorter sides, so again, looking at where our included angle is for this triangle, the side that is opposite, which is the one down here, would be our opposite. The one that is next to it is our adjacent. And that's how you label sides. If you haven't yet, pause the video and copy these notes in to your maths book right after where we finished off last lesson. So put in the labeling sides, have both diagrams in, including the names here. I'll actually put a cloud around them, just so you're not having to try and remember what those words are. You've got it there in your book. All right, once you've got that stuff in your books, let's look on and have a go at some questions yourselves. So what I want you to do is pause the video, copy in the questions, and have a go at labeling the sides of each one of these triangles exactly the same way we did on the previous page. Okay, so hopefully everyone's had a chance to do it. Let's go through and have a look at your answers. So for this one here, hopefully you should have had adjacent at the top, opposite down here, and this one was the hypotenuse. This one here, I should probably do it in the same way I recommend it. You know, label the hypotenuse first, the longest side, the one opposite, and the one next to the included angle. And for this one here, it doesn't matter how you rotate the triangles. The hypotenuse will always be the longest side, the one that is opposite the right angle. The opposite will always be the shortest side that is opposite the included angle. And the adjacent is the one next to the included angle. All right, so hopefully you feel okay with labeling sides. If you need to go back and rewatch this little section again, please do so. Make sure you can label the sides because you will need it for the trig ratios. All right, so you know from your calculator, we're going to be covering 3 trig ratios. These are the most important ones, pretty much the only ones you're probably ever going to need, at least for the majority of you. All right, so how do we find, well, what are the trig ratios? I've got this random thing called SOHCAHTOA up here. This is used to help us remember what the trig ratios are. Lawson, shh. All right, so first one, SO. What does this stand for? Well, this stands for, the S stands for the sine, the first of our trig ratios. And this sine ratio, right, is going to be equal to, well, we have, if you check out the rest of SO, it's O and then H. O we know stands for opposite, H stands for hypotenuse. So when we're trying to find our sine ratio, all it will be is just the opposite divided by the hypotenuse. That's all we need to do. We just need to know what those two sides are and then divide them. If we look at the next of our trig ratios, it's the one that has the capital C. That stands for, if you look at your calculator, the next button along, it's the cos button. So this cos ratio will be, and if you check out the rest, it tells you right there, it's the adjacent side divided by the hypotenuse. And the final trig ratio, capital T, that stands for our tan ratio. And so tan theta would be, yep, you guessed it, the opposite side divided by the adjacent side. All right, so trig ratios, SOHCAHTOA, nice and big, and our 3 trig ratios beneath. Make sure you have these copied into your books. Pause the video if you need to. Get them copied into your books nice and neat. And once that is done, press play and we'll continue on. Okay, so on to our example. So we've got this right-angled triangle. One side's 3 meters, the other side's 4 meters. There's an included angle, which is currently unknown, right? We'll learn how to do that next week, how to actually find the size of these angles. We will need the trig ratios, right? Well, what we're covering today is, hey, how do we find what these trig ratios are going to be? Well, let's have a look. So we want to write down the 3 trig ratios. So what is sine theta going to be equal to? Cos theta and tan theta. And we know SOHCAHTOA, sine, cos, and tan. This is how you find them. So what I would be doing if this was an exam, I'll write SOHCAHTOA. All right, so if I want to find what sine is equal to, right, I'd be looking at this one here. Sine is opposite over hypotenuse. Now, that's going to be easy enough, right? So you go over, look at the triangle. What is our opposite? What is our hypotenuse? Okay, here we go. We've got none of the sides labeled. Good thing we just learned how to label the sides. This will be our hypotenuse. This will be the opposite, and this will be the adjacent. Now we've got a slight issue here with sine because the hypotenuse, as you can see, we don't know the length of it. We've got this situation where we know two of the sides, the third one's missing. How do we do that? Fortunately, there's this guy, his name is Pythagoras. We covered it, right? We're trying to find the length of the hypotenuse. I told you it would come in useful. 4 squared plus 3 squared. Type it in your calculator, press equals, it's 5 meters. Okay, so we've found the length of this missing side, that is 5 meters, and now we're good to go. So our sine ratio will be the opposite divided by the hypotenuse. It's 3/5. You can actually, because that doesn't simplify at all, you can leave your answer like that as a fraction. If you really want it as a decimal, you could type it in, you know, get your 0.6. You certainly don't need to. I personally am just going to leave them as fractions as one less thing to do. All right, the next trig ratio, how do we find the value of cos theta? Well, that's when you look back up at SOHCAHTOA, right? Because you probably don't have sine, cos, and tan memorized yet. Right? We only just wrote them down. So instead of trying to memorize all three, I just think of, okay, SOHCAHTOA, we're trying to find cos. Cos is A and H. That tells us cos is A over H. And then so typing that in, well, we look at the triangle. The adjacent is 4, hypotenuse is 5, and you're done. It's as simple as that, right? You just, once you've got the sides labeled, you know which sides are which. Cos is A over H, so it's just 4/5. You could write 0.8 again if you're really set on having decimal answers, you can. But I'm just going to leave it like that. And the final one, tan, let's pick a new color. Let's go with this one here. All right, so we're trying to find the value of tan theta. All right, first things first. Hey, you got to SOHCAHTOA. Here we can see tan is O and then A, right? In that order, right? Tan is O first and then A. So it's just going to be the opposite divided by the adjacent. And the tan theta was actually just 3/4 or 0.75. That's how you find the trig ratios. So what's the plan? Right? If any of the sides are missing, use Pythagoras' theorem to find the missing side. That's what we had to do here. This was an annoying one. Normally they give you all three sides, to be honest. So once you have all three sides, label the sides. Which is the hypotenuse, which is the opposite, which is the adjacent. Once you've got the sides labeled, you can then go to SOHCAHTOA, and that'll tell you which ones to use for each. And the order that it's written, if sine is O and then H, make sure you put the opposite first and then the hypotenuse on the bottom. And that's how you do it. So pause the video, have this example, copy it into your book so you've got it all there. Once it's done, nice and neat, play the video and we'll finish off this second lesson. All right, here's 2 questions for you guys to do yourselves. So I've given you 0 measurements because I am clearly disorganized. This is 5 meters, 12 meters, and this can be 13 meters. And for this second one here, we can have, gosh, I don't know, let's have 9 meters, 12 meters, and the last side I'll leave blank. All right, so this is your plan. Pause the video, find the values of the 3 trig ratios for both triangles. Once you're done, unpause the video and we'll have a look at the answers to see how you went. Okay, hopefully you were successful. So with the first one here, I'm going to start by labeling the sides. We have hypotenuse, opposite, and adjacent. And because I only just learnt trigonometry today, right? This is our first lesson with it. I don't have it memorized. I'm not expected to have it memorized. What I'm going to do is I'm going to write down SOHCAHTOA because that tells me everything I need to know. All right, so for sine, Sine is going to be, I'll keep it in green. Sine is opposite over hypotenuse. There it is. There's the sine one done. For cos, it's adjacent over hypotenuse. And tan is opposite over adjacent. So hopefully you got them for the first question. Definitely give yourself ticks if you did. You're doing great. For this one here, again, we've got that situation where one of the sides is missing. So we rock out our Pythagoras' theorem. It's a hypotenuse, so I'm going to use a plus. Remember, if it was a shorter side that was missing, I'd be using a minus here in the middle instead. Anyway, typing this in, I believe you get 15, hopefully. Anyway, so you find your missing side. Now we're going to go ahead and label them. I'll do this question in red. Hypotenuse, opposite, adjacent. So sine is opposite over hypotenuse. Cos is adjacent over hypotenuse. And tan is opposite over adjacent. And that is it done. Admittedly, I will say these can be simplified in an exam situation. Unless the question said to simplify it, you actually would have full marks here. So if you got these fractions, definitely give yourselves ticks. You've got full marks. But just for those people that took it a step further and actually simplified it, you know, the factor of 3 goes into all of these. So they simplify on down. To that. So you know, either would be fine. All right, hopefully this made sense. And go through the Education Perfect lesson. If you have any questions, just leave comments either here or on Canvas. I'll see it either way. Best of luck, and I'll see you for the next one. All right, bye.